The first week, which is this week, is dedicated to two important questions. Why quantum computers are so powerful, and why it is so hard to implement them. Because, as you probably know, there's no useful quantum computer implemented in the world up to this time. No math above the school level is required for understanding this weak material. And this week is enough for those of you who are just interested in basics of quantum computing and don't want to dig deeper into it. The second and the third weeks are about the mathematical model of quantum computing and how it grows out from physics. The students who study the mathematical model in the introductory course often ask questions about the origins of mathematical model. Here, instead of introducing mathematical model as is, as we did in the introductory course, we are going to explain where it comes from. Some more prerequisites are required here. I assume that you understand what a differential equation is, and what is a solution of a differential equation, and what a complex number is, and functions on complex numbers, etc. Also, we will use the notion of a vector space and basis of that space. The fourth week is all about the mathematical tools of quantum mechanics. As always, I don't expect from you any background in quantum mechanics, but its mathematical language is used everywhere in the field of quantum computing. This week is very much connected to the material of the second and the third weeks. Since the course name promises less formulas, I'll try to uncover only the tip of the iceberg here. Still, it will be very useful for you if you are going to continue learning and take the introductory course, for example. On the week 5, we will consider some basic algorithms concerning quantum teleportation and quantum cryptography. So, however the course name says less formulas, it does not mean there will be no formulas at all. Still, the course material is more focused on understanding than on calculations and rigorous proofs. I hope you will enjoy it.